When we talk about problematic slab conditions, we come across certain things that have come to be noticed as major issues with the installation of new floor covering. Things like moisture, excessive moisture in a concrete slab, porosity in the slab or lack of porosity, usually caused by slabs that have been polished or densified in some way. We talk about contamination through the chemical abatement process, surface contamination, or even contamination from within the slab itself. And then we talk about adhesive residues and what they might mean for bonding with new floor coverings or floor preparation materials. These are the common issues that we're going to discuss today. So let's jump right in and talk about moisture-related issues. So when we talk about moisture, some of the things that you can expect to experience if moisture is not handled on the front side of the installation are things like bond failure, mold and mildew growth, discoloration of flooring materials. But mainly the main thing you're going to experience is some sort of compromising of the floor covering that's installed over that slab. Things like curling or cupping, blistering or bubbling of the floor. Anywhere that moisture can find a release point out of the slab is normally what's going to be compromised. And there really is no way to fix or repair it without removing the floor covering and almost starting the application fresh. So you're probably looking at a situation where it's going to be a full replacement of that floor covering. So this next slide here basically illustrates what we're talking about. So starting on the far left, you see a situation there where you have a sheet vinyl, and moisture has basically attacked the path of least resistance. So it happens to be on a seam between two sheets. That's kind of the weakest spot of the floor, and you see moisture is releasing itself through that seam. In the next slide there, you see a wood plank on the top, and then that kind of coincides with that parquet wood below there, where wood flooring is not it is a moisture-sensitive floor covering. So moisture has basically released itself through one of the joints, but it's also affected the wood itself. It's kind of twisted it and warped it to a degree. And then you have some surfaces there that show an epoxy coating or even a paint over the surface of that floor, where things are starting to peel from excessive moisture coming up from the slab. And then you see a couple of slides there too, or pictures where we're showing mold and mildew that can grow because of the excessive moisture. So situations like this lead to certain outcomes. Most of what I already discussed, there really there's no way to repair these situations. Repairing these situations is only going to prolong the inevitable, which is full replacement of that floor covering. And then you're dealing with, questions about who's responsible for the added costs. Warranty issues come into play, and then there's always this push-pull scenario between the contractor and the general contractor about the reputation, and again, ultimately who is going to be responsible and who is going to have to incur all these costs. When we talk about traditional approaches to dealing with moisture, we first have to realize that all concrete slabs should go through a method of testing to decide first and foremost if there is a moisture issue in that slab. And when we test via either the calcium chloride test or the RH probe test, we have to understand that whatever readings we get are only a snapshot in time. And we have to know that those levels of moisture in that slab can change, right? They're only a snapshot or a window into that time, right? So moisture levels can change, and we need to recognize that, because anything that's above or below grade or on or below grade should be mitigated. That's really the message we're trying to say here. So when in doubt, it should be automatically assumed that some sort of moisture treatment should be applied to that slab The traditional method of mitigation at that point has been a shot blasting of the surface, right? So shot blasting, usually a surface profiling of between a 3 and 4, and then an application of a traditional two-part epoxy mitigation system, which works to provide a shield over the surface, if you will, that blocks moisture vapor from penetrating out of the slab. So Maxxon has a number of solutions in our line, beginning with a product called MVP two-part epoxy, which would be our traditional type product. And then we have some newer formulations, including a product called MVP1, which is a primer type mitigation solution. Unlike a two-part epoxy, it is a single component material. It happens to be a lot less labor intensive and more cost efficient. Just works on a different chemistry than a two-part epoxy. And then we're even going to mention here a product called Maxxon Commercial Isolate, which really serves twofold, has two main purposes when you would use it, one of which is to block moisture vapor from coming out of the slab. So we'll start with our traditional method of mitigation. This is our basic two-part epoxy called MVP two-part epoxy. No secret bells and whistles here. Part A gets mixed into Part B. It must be applied over a profiled surface, and when squeegeed out over the surface and allowed to dry, it's going to provide moisture mitigation protection of up to 100% relative humidity and 25 pounds of MVER. The single component material, MVP1 primer, is a much more efficient and economical solution. It does not require a surface profile, so no shot blasting involved to apply it. It does, though, require porosity of the surface or absorption of the surface. So best thing to do there is to test via the water drop test. Make sure you have good porosity there, and then you're good to go with 2 coats right out of the bucket. No water dilution is necessary, and the first coat would be applied in a north to south direction. The second coat would be applied in the east to west direction, and you'll get the same protection, notice, as you would out of a traditional two-part epoxy, which is up to 100% RH and 25 pounds of MVER. You'll get a coverage of 1,250 square feet out of this bucket in the 2-coat application, as opposed to about 375 square feet from the two-part epoxy that we mentioned earlier. And the last product that kind of falls under this category is the Maxxon Commercial Isolate. Commercial Isolate is a 2-part water-based epoxy, but the biggest difference between a traditional mitigation epoxy and something like this is the product does not require a surface profile, and it doesn't even require porosity as we saw in the MVP1. So this is a really low-cost, less labor-intensive alternative to one of the other two, but the protection is not as stout, if you will. You're going to have a protection of 100% RH, but up to 14 pounds of MVER in a single coat. And if greater protection is desired, you can do a 2-coat application, which would bring your protection up to 19 pounds of moisture vapor emission. Okay, so that takes us to the end of the section about moisture mitigation. The next situation we're going to talk about deals with porosity or densification of the slab. And essentially what that means is that the pores of the concrete have been sealed off to a degree, either through chemicals or through a process like polishing of the slab. And I took this kind of verbiage from the Ceramic Tile Education Foundation, where you see there, it says finishing techniques along with the use of some types of concrete additives can also affect the ability of a mortar or adhesive to form a good bond. Steel or rotary troweled concrete produces a dense glass-like surface, which makes it difficult for a mortar to develop a mechanical or adhesive bond. So that's basically what we're going to be talking about in this next section. And you see these pictures here that are included on this slide. So the first 2 pictures from right to left show a slab that's in the process of being polished, right? So this is a wet grind scenario in this first slide. that's leading to the finished result, which is shown in this middle slide. So you can imagine if at some point in time when floor covering now is going to be asked to be applied over a surface like you see in that center picture, there really is no porosity in that slab to promote a good bond. And you may get a situation like that is shown in this third picture here, where we see some ceramic tile that's come loose, and when the tile is removed, you see all that thin set mortar, or most of it anyway, has stayed with the back of the tile, and the surface is clean. And that kind of really drives home the point that we just discussed, is that there really is no porosity there. The pores of the concrete, which would be normally asked to promote that bond, have been sealed off, and it's very hard for things to bond at that point. So again, the effects that we're dealing with when we talk about lack of porosity or a densified slab heavily deal with bond failures, and bond failures between the adhesives and mortars, and the floor covering. But really, bond failures when you talk about anything that has to go to that slab, anything from patching compounds or self-leveling underlayments that are going to be called upon to repair the surface in preparation for the new floor covering, or even mitigation solutions we saw earlier, that have to absorb into the pores of the concrete, so to block moisture vapor. And then even epoxy coatings and floor systems that would go over the top and act as a finished floor system. All these things can be affected by trying to apply them over a surface that's where the pores of the concrete have been closed off. So again, we see outcomes, right? We're dealing again with bond failures from everything between the adhesives and the mitigation and the subfloor preparation products. In addition to bond failures, densifiers can also inhibit how fast the moisture vapor releases from that slab. So you can get greater internal RH levels where moisture is not being able to escape. So you could actually create a situation where you have a high moisture situation when in all actuality you really don't. It's just that the pores of the concrete on surface have been sealed off so well that it's slowing the amount of or the rate at which moisture would normally escape from that slab. What's required next is to create some sort of porosity, either through grinding or some sort of surface profiling. And then once you choose to mechanically profile, you got to deal with what comes from that, which is the promotion of dust and noise. So traditionally, when we talk about dealing with, a non-porous slab, if we were going to follow through with an application of floor covering at this point, there's some things we need to consider, right? So the first thing we want to try is we want to maybe follow through with some bond tests with the adhesive that's normally used for whatever floor covering is going to be applied. Might not be a bad idea to trial some small tests in different areas across that space. Make sure we're getting a good bond. And if we're not getting a good bond, which is likely going to be the case, there are several other things you could do. You could trial different types of adhesives or mortars. So, there are urethane adhesives or acrylic-based adhesives that might promote a little bit better bond. When it comes to ceramic tile, there's different types of mortar, some that are polymer modified or some that have a more heavily polymer modified than others. And then if you're talking about patching compounds or self-leveling materials to smooth over that slab, you might want to try a calcium aluminate or even a gypsum-based, which tend to shrink less than a Portland-based product. And if it was Portland and it shrinks a lot, it's going to pull right off that smoother, sealed surface. But above all, when dealing with bond issues, you should consult the manufacturers for their recommendations. That could be the manufacturers of the floor covering, the adhesive, or even the floor prep materials. And almost certainly they're going to recommend some sort of profile to create porosity and or absorption in that slab. So this next slide talks about what Maxxon has to offer to promote porosity. And we have a product called Maxxon Commercial Profile. So this is a way to achieve that porosity and or a texture of the surface without the necessity of mechanical tooling. When spray applied to the concrete, it will start a chemical reaction. And depending on how long you leave it on the surface, it will either clean the surface, and for situations where you need to promote or get a texture to the surface, you leave it on a bit longer and it'll start texturizing or creating a profile of that surface. So the big take home in this product is it must come in contact with the surface of the concrete. If there's adhesive residue, if there's paint over the surface, that's going to prohibit its ability to react with the salts in the concrete, then it will not work. So we want to make sure that there's nothing blocking its way from penetrating the pores of the concrete and reacting with the minerals in that slab. And as I said, it's going to clean and profile the floor depending on how long you leave it on the surface. Ideally, you can use this for heavily densified slabs as well. So here on this slide, you see some pictures that show how the material is applied and then what kind of reaction you're going to experience, right? So the material gets spray applied to the surface of the concrete, and when it comes in contact with the concrete, it attacks the salts in the concrete and it forms a reaction. And that reaction, depending on how long you leave it go, either from 15 minutes to 4 hours, you'll have a product here that is either going to just clean the surface of the concrete. Maybe you have a contaminant on the surface that you're looking to remove, and that's going to be in that 15-minute to 30-minute dwell time, if you will. And then if you're looking to achieve a greater texture or a profile in that concrete, you're looking at more in that 2 to 4 hour dwell time before the material is ready to be removed. When it is ready to be removed, you're going to spray apply or hit it with some water, which causes the solution to neutralize. So it stops the reaction and it neutralizes the solution. And then the method of removal could be one of three things. If you are fortunate enough to be working in a space where there is a floor drain, you can basically flood the water to the drain with a hose or a power washer. If you're working in a smaller space, then you could flood the space with water. Use a squeegee along with a good shop vac, a wet dry shop vac to remove the solution. Or if it's a larger space and you have access to an auto scrubber, that would be the ideal method of removal there. Okay, so the third issue we want to talk about today is what if you have the need to install floor covering in a space that's been chemically abated or has a surface contaminant on it. So when we talk about the chemical abatement process, there's usually two results that you get from a chemical abatement process. And the first one is we know that the abatement companies don't always do a pristine job to remove the solutions that they use to kind of dissolve and break down these asbestos-ridden adhesives. So there's almost always going to be a known contaminant on the surface, either something petroleum-based or soy-based that they used to break down those asbestos adhesives, right? And if it is, to tackle that surface contaminant, I just put there in red. You see, you can always start with an application of Maxxon Profile to remove any of those surface contaminants to make sure whatever you're going to bond to the surface next is going to stick, right? The second thing you want to think about when there's a chemically abated surface is there's a lot of water that's used in the removal method. So the first step is to use a solvent-based material to break down the adhesive, and then there's an awful lot of water that's used to thin out that solution so it's easily removed with a industrial vacuum, shop vac. But during that process, a lot of the material that doesn't get collected actually absorbs back down into the pores of the concrete. And at some point later, they can migrate back out of the slab and affect the integrity of the floor covering materials that are installed above. Okay, so that's the abatement process. There can also be several things that go on a job site that cause surface contamination. You can have remnants of oil and grease from something like oil-based sweeping compounds, or there can be paint that was used to mark off different areas where electrical wiring or piping for plumbing has to be installed. They usually mark the floor with some sort of marking paint, and that could be a surface contaminant that prohibits bond as well. We want to make sure that we take the proper steps again up front to avoid a situation of having to repair or replace the floor afterwards. So on this slide, I show 3 examples here of what can be described as contamination to the slab, right? So on the left, you see a job that's basically in the process of being chemically abated, and they started with the center portion of this room here, and they've probably used maybe a combination of a solvent to break down the adhesive and then some other things to wash over the surface. And you see they haven't really attacked the perimeter yet, but there's no way that one could call that portion that's already been cleaned free of contaminants, because you still see some remnants there of petroleum-based adhesives or solvents. So in the second slide, that is just a close-up picture of a mechanic's shop where there's been some oil and grease spots over the years, and maybe this space is being turned into an office space or a retail space or something like that. And what do you do when you have situations of this grease and oil that have been dripped on the surface of the concrete for a few years? The third slide, the third picture there is just of oil, a picture of some oil-based sweeping compound. I mean, there's been situations where at the end of every job site, the GC has somebody sweep down that space, and they use these compounds to keep dust down, and they really don't understand that every day that they use this product, they're basically contaminating the surface that the floor covering installer now has to deal with when he goes back to install floor covering or prepare that floor. Sometimes he doesn't even know that this product was used. So you can imagine the failures that can occur if you don't know and you couldn't treat something up front. Again, hopefully you're starting to see a theme here. Some of the outcomes that you can expect to experience with a chemically abated or contaminated slab. Again, bond failures between adhesives and floor coverings to the surface, any surface preparation materials or mitigation systems. These can all be points of failure with bond if that slab is not treated properly up front. And then you're dealing with added costs to clean the surface contaminant, and then ultimately do something to lock down the abatement chemicals that might have absorbed into the slab during that process. And here we're talking about warranty and liability issues again. It's always going to be that push-pull between the abatement contractor and the flooring contractor to decide who's responsible or who's going to fit the bill for these added costs. Traditionally, the ways that these chemically abated surfaces have been dealt with, the preferred method of asbestos removal in the past has always been a dry abatement process, which usually is some sort of shot blasting or grinding or profiling of that surface. But they create a lot of dust, a lot of noise. So there may be a situation where the space or the environment that you're being asked to work in is a dust-free environment. Maybe it's a healthcare facility or it's a food preparation facility, and dust is out of the question. And at that point, this chemical abatement process has taken over. It also happens to be a little bit more cost efficient, but that's before you figure out what the added costs are if you don't do it right and you don't remove the contaminants from the surface. So again, the method of choice has been to shot blast the surface to a pretty rough profile of a 4 to a 5, which is enough to remove the surface contaminants and also get into that concrete slab to hopefully remove some of the the contamination that's seeped into the surface a bit, right? And then the next step would be to apply something like a sealer to the cutback, to lock down, cutback adhesive residue, and then follow through with some sort of preparation to get that floor now ready to accept the new floor covering. At that point, you'd let it dry, let everything dry, and follow through with your floor covering. But at this point, you're really rolling the dice because it's likely that something is going to rear its head over time. And that's where Maxxon Commercial Isolate comes into play. So what is the commercial isolate material? Well, we talked about it earlier under the section for moisture mitigation, so I'll start there. If any of these abatement chemicals have migrated into the slab, what would be the carrier of those chemicals from coming back out of the slab? Well, that would be moisture. Again, isolate mitigates moisture, and you see there again up to 100% RH and 14 MVER in one coat and up to 19 MVER in two coats. So that's the first thing that it does, is it basically locks down those chemical abatement residues and asbestos adhesive residues from being able to migrate back out of the slab, which would in turn affect any of the new finishes that are put on the top. Okay, so it'll block out moisture, and again, it locks down any of these harmful contaminants from coming back out of the slab, eventually maybe compromising the integrity of what's put over the top. It's a two-part water-based epoxy, so when part A goes into part B, it comes out looking like a red color paint, which is great because it gives you the ability to see how your coverage is. You want to work this product into all the nooks and crannies in the floor. Make sure you're covering it really well. Don't allow the material to puddle. So if it does seep into a crevice or a hole in the slab, you want to brush that away so it doesn't puddle. And you want to make sure that you're holding this material to a 600 square foot per unit coverage. So it may take the necessity of putting across the slab some sort of grid pattern with your chalk lines so that you know that one unit covers 600 square feet, because over the surface it will cover like a paint, so it will go further if you allow it to, but this needs to be put down at the correct mill thickness. So you want to kind of grid off your sections and hold each unit to a 600 square foot coverage. And then this is an example of what the product does. So you see we have a contaminated surface, and that's either oil or maybe some old cutback adhesive residue. We've applied some isolate there, and over the top of the isolate we floated some floor patch, making sure that we kind of overlapped onto the surface that wasn't treated. So you can see how the oil absorbs up through the patch, but not in the treated area. So you see where isolate is, it's not allowing anything to come up through that patch and affect it. It's locking down the harmful contaminants from affecting what's above. So the next section I want to talk about is with regards to excessive adhesive and glue residues. Basically, the effects here, would be, when a space goes under renovation and old floor covering is removed, it could expose a lot of different adhesives, asbestos-related adhesives. But the real nemesis here is what we refer to as PSAs, or pressure-sensitive adhesives. These are really aggressive, tacky adhesives that are meant basically to allow for the removal and reapplication of floor covering, so they stay tacky. And you can imagine when the floor covering is removed, depending on the degree of tackiness that's left, this can prohibit foot traffic through that space. So if it's an office space that's under renovation, it can definitely affect the traffic patterns of that office space, because it will literally pull your shoes off as you cross over it. Existing pressure-sensitive adhesives, if they're left uncovered for long periods of time, let's say the renovation of the old floor covering was removed at the beginning or the front side of the job, then you're going to expose the surface of that adhesive to all the other job site debris, which can fall to the surface of that adhesive and bond to it. Things like wire clippings or dust from drywall or just drywall debris in general. Just making that whole removal or cleanup process before the new floor is put down just makes it more difficult and more costly, because there's different things that have to be done here. These are some examples of the type of adhesive that could be left behind. So on that top left-hand corner, you see basically some old carpet mastic. Maybe this was put down a little too heavy. When the carpet is being removed, if you're going to put down a different type of floor covering, this has to obviously be removed, and you can see the difficulty that's being can't just be scraped. More likely looking at some sort of a solvent or a mechanical removal system here. On the right-hand upper corner, you see someone who's basically using a solvent to try to break down some of the adhesive and kind of wipe it off the floor. And that's a process, and as we said earlier, you're leaving a contaminant behind in this situation, which also has to be dealt with. And then these bottom two shots are showing, most likely old cutback adhesive that's got some asbestos to it. And on the right-hand lower corner, you see these two gentlemen who are suited up to do a chemical abatement or wet scraping at the very least. But there has to be some sort of asbestos that's in that adhesive because of the way they're dressed. So again, keeping with our theme, what are some of the outcomes here? Well, you're talking about some really costly processes to remove those adhesives. If mechanical removal is the removal method of choice, then you're talking about dust and noise. And there may be environments that you're working in where dust or noise will not be tolerated. And those are typically your healthcare or food preparation areas. Okay, and then we talked about the use of solvents in something like a chemical abatement process. Okay, well, it gets the adhesive off the floor, but it leaves surface contamination and even contamination that's within the slab. And then we're talking about the same thing of bond warranties, issues, with things being applied over top of these old adhesives and whether or not they're actually going to stick. So traditionally, when you're dealing with floor spaces that have old adhesive residue, mechanical grinding or removal has been the method of choice. And you're talking about grinding, shot blasting, scarifying, or sanding. These tools require some sort of grinding discs or stones or pads that when they get gunked up with adhesive, they're not good anymore, and they're not cheap. So to continue that method with and knowing that you're going to go through a number of these different components of the grinding or shot blasting or mechanical removal method, it could get costly, right? Because these things are going to be thrown in the garbage when they get gunked up with adhesive. So if mechanical tooling is not the choice, then we're talking again about solvents and chemical scrubs, much like the abatement process, and then you're talking about contamination. And then the last choice here, which is not the best choice at all, is to do some sort of encapsulation. And at that point, somebody is going to do something to the surface of that adhesive to allow them to get the job done and go over it. That could be applying, a patching compound. It could be dusting of the floor to break down the adhesive and wet scraping off some of the adhesive, but not all of it, and going over top with the new floor covering adhesive and or floor covering, and that could cause issues if the two adhesives are not compatible with each other, which more often than not is the case. That's where Maxxon Commercial Unglued comes in. Maxxon Unglued is a way, or it's a product that's used to remove adhesive residue from a concrete or wood slab without the means or the necessity of mechanical tooling. Basically going to apply this material over the adhesive, the old adhesive. You're going to let it dwell for a period of time. Usually the normal dwell period is between 2 and 4 hours. It's going to work to absorb into the adhesive, and it's going to cause the polymers in that adhesive to swell. And that's what's going to compromise the bond enough to allow you to get underneath it with a basic razor scraper and remove it from the surface. So it's a dust-free alternative to a mechanical removal process. It's obviously going to be safer because you can remove it in either a wet or dry process, and the wet process would allow you to keep dust particles from getting airborne if it happens to be an asbestos-ridden adhesive. So here we have a couple of pictures. The one on the left shows how it's applied. So after it's mixed, you basically apply it with a 3/8 nap paint roller to the surface of the adhesive. Just a good even coat over the adhesive is all you need. And then you're going to walk away from it for about 2 to 4 hours. And on the right-hand side, you see how easy it is removed with just a basic razor scraper. These are some more pictures that show the removal process. So again, just basically getting underneath the adhesive with a good quality razor scraper takes it right off the surface. And then the material that's removed can be easily collected and bagged because, again, it's non-caustic, non-toxic, and biodegradable. So those are just a few products in the Maxxon commercial portfolio of materials. We talked about moisture mitigation and some of our specialty offerings. We have a whole gamut of other products to make the use of those products a full system. Maxxon has been around for 50 years. We've created floor preparation materials for the multifamily space, and now we're taking our experiences along with some new solutions and technologies to solve problematic slab conditions in the commercial construction and renovation space. If any of these products are interesting to you and you want to learn more, please go to our website, which is www.maxxon.com, and you can find a section there called Find Your Rep, and it'll take you to this page where you'll be able to find the sales manager in your area, and we hope to hear from you soon. Thank you.